Now we tell the problem is find the area bounded by the curve. Here we have two problems. First one is y is equal to sin x. Second one is y is equal to cos x. Boundaries are x-axis and x is equal to 0, x is equal to 2 pi. Now we can find the area of these two curves. First we can take the given equation of the curve. First problem, the given equation of the curve is y is equal to sin x. This is taken equation number 1. Now we take the boundaries. The boundaries of the region are x-axis, x is equal to 0 line, and x is equal to 2 pi line. We know that sin x values are greater than or is equal to 0. Whenever sin x values are greater than or is equal to 0, that means the functional values are positive. Greater than or is equal to 0 means they are positive values. Whenever possible, we take Q1 quadrant, Q2 quadrant, Q3 quadrant, Q4 quadrant. Here in the Q1 quadrant, all functions are positive. This is origin O, this is x-axis, this is y-axis. Here all functions, this is 0 to pi by 2. The angle is between 0 to pi by 2. Theta values are between 0 to pi by 2. Okay, so here all functions are positive. Next, in the Q2 quadrant, only silver, all silver teacups means here sine function and cosec functions are positive, remaining are negative. Okay, so in the third Q3 quadrant, we have tan and cot functions are positive, remaining are negative. Here cos and secant functions are positive, remains second has negative. Now we can observe here to here 0 to pi by 2. Okay, 0 to pi by 2. Next, here to here pi by 2 to pi. Next, here to here we have pi to 3 pi by 2. Next, here to here we get 3 pi by 2 to pi. So 0 to pi by 2. This Q1 quadrant angles are from 0 to pi by 2. In the Q2 quadrant, the angles are coming from pi by 2 to pi. In the Q3 quadrant, that means pi by 2 to pi. Theta values come from pi by 2 to pi. In the Q3 quadrant, the theta values take from pi to 3 pi by 2. Okay. So in the Q4 quadrant, the theta values are coming from 3 pi by 2 to 2 pi. Okay. So like this we can take. Here sin x values are greater than or is equal to 0. That means sin x values are positive in Q1 quadrant and Q2 quadrant. Here all are positive. Here sin functions are positive. Only Q1 quadrant, Q2 quadrant, the sin functions are taken as positive. So that means 0 to pi. The sin values are positive for all x belongs to closed interval 0 to 5. Okay, so inka cheppali ante, so we take the 0 to pi by 2 union pi by 2 to pi. equal to 0 whenever x belongs to 0 to pi. Okay. So now we take the rough graph of y is equal sin x function. Rough graph we can take it. So first of all we take the table y is equal to sin x table. X values, y values, first 0 to 2 pi, the given interval is 0 to 2 pi now. For that we take it first x is equal to 0. When x is equal to 0 we get it sin 0. Sin 0 is equal 0. Then y is equal 0. Next values pi by 2 we can take it. Sin pi by 2. Sin pi by 2 value is equal 1. Next point we take it x is equal to pi. When x is equal to pi, sin pi we get it. So sin pi value is equal 0. Next 3 pi by 2. With the difference pi by 2 we take the values of x. Okay. So 3 pi sin 3 pi by 2 value. So that is minus 1. So next 2 pi. Sin 2 pi value is equal 0. Sin 3 pi by 2 value is equal minus 1. How? We will tell about that. Sin 3 pi by 2 value is equal minus 1. So sin of 3 pi by 2 can be taken as pi plus pi by 2. Okay? Pi plus pi by 2. So take LCM 2 pi plus pi, 3 pi by 2. Okay? 3 pi by 2 can be taken as pi plus pi by 2. Now, here we have pi function and this theta, pi plus pi by 2 is goes to Q3 quadrant. In the Q3 quadrant, sin functions taken as negative. Okay, we take negative because sin function only in Q1 and Q2 taken as positive. Q3 quadrant, Q4 quadrant, the sin function is taken as negative because in the Q3 quadrant tan theta and cot theta are taken as positive, remains as negative. That's why we take negative. Here pi function now, so if you ask this we can take sin pi by 2 minus sin pi by 2. So minus sin pi by 2 value is minus 1. Okay. So sin pi by 2 value 1 we get it minus 1, minus 1 totally we get sin 2 pi by 2 is equal minus 1. Okay. Now these points are taking the graph. So only positive side now. So for that we take the graph. This is x-axis. This is y-axis. This is origin O. With the difference pi by 2 we take the points. Okay. So 0 to pi by 2. Pi by 2 point. Next pi. Pi we can take it. Next 3 pi by 2. 3 pi by 2. Next 2 pi. Okay, 0 to 2 pi we get the points. We take the points on the x-axis. Now on the y-axis the difference 1. 0 to 1, 1 to 2, like that we can take 1, 2. Here minus 1, minus 2. Okay, so now the point is 0, 0. Here pi by 2, 1. Here pi, 0. 3 pi by 2, minus 1. 2 pi, 0. All these points fixed in the graph. So first point 0, 0. That is we get it here. So here x is equal 0, y is equal 0. So this point. Next pi by 2, 1. X-axis means pi by 2. Here on the y-axis we take 1. So coincide point is got it here now. So pi by 2, 1 point is exist here. So next pi, 0. Pi on the x-axis pi, on the y-axis 0. So we got it pi, 0 here. So next 3 pi by 2, minus 1. 3 pi by 2 is this one, minus 1 on the y-axis this one. Coincide point is here we get it. Next 2 pi, 0 on the x-axis 2 pi, y-axis that value is equal 0. Okay. comma 0 is here. So now join all the points. Like this we get in the area. Our required area is this one. Okay. So this is O. Next this point is taken as A. This point is taken as B. Next this point is taken as C. D. Okay. So required area we get it OAB area plus BCD area. Okay. So now we can take the required area. The required area A equal integral. Now first part, the area of the region. The area of the region OAB plus the area of the region BCD. These two you can find and add it. Now we can take A equal first one area of the region OAB. OAB we can take it. So that is here we can observe that the intervals are taken from x is equal to 0 to x is equal pi. X is equal to 0 to x is equal to pi. So here you can see 0 to pi now x is equal to 0 to x is equal to pi. This area is bounded x is equal to 0 to x is equal to pi. Okay. So intervals are taken from x is equal to 0 to pi. Here the function y is equal to sin x now, sin x dx plus next one the area of the region BCD. BCD taken the intervals from pi to 2 pi. Okay. Here the point is pi, B pi. Pi, here the point is 2 pi. Okay. Pi to 2 pi sin x dx. Now we can find here the area na. So for that we take the modulus to. Now A equal modulus integral sin x. Formula is minus cos x. Taken the intervals from 0 to pi. Plus here also integration of sin x equal minus cos x. Take modulus minus cos x. Intervals are taken from pi to 2 pi. A equal modulus, applied the upper value minus lower value, minus cos pi minus into minus cos 0 plus modulus minus cos 2 pi minus cos pi modulus plus. Now A equal minus cos pi. Cos pi value is taken here. Cos pi is equal to minus 1. Okay. Minus into minus plus cos 0 value is equal to 1. Plus minus cos 2 pi. Cos 2 pi is taken as 1. Minus into minus plus cos pi value is minus 1. Modulus. So now this value is equal minus into minus plus 1. 1 plus 1 plus minus 1 minus 1. Minus 1 minus 1. That is equal. So here 1 plus 1 2. Modulus 2 plus modulus minus 2. That equal 2 plus 2. 2 plus 2. A is equal 4 square units. A is equal 4 square units. 4 is our required answer. Next problem. First of all, we take the given equation, second problem solutions. The given equation is y is equal to cos x. Boundaries or x-axis, x is equal to 0 line and x is equal to 2 pi. 0 to 2 pi, we take the two values 0 to 2 pi. We know that cos x is greater than or is equal to 0. Cos x is greater than or is equal to 0 when for all x belongs to, you can adjust x values whenever we can take the cos x is equal to positive. Cos x is positive in Q1 quadrant. Q1 quadrant theta values are taken from 0 less than theta less than pi by 2. Okay, here all are positive now. So for that we take it 0 to pi by 2, take it as positive. Next, union here also in the Q4 quadrant, take the values are positive because Q4 quadrant algebra cups place will be taking cos function and secant function positive now. So for that this Q4 quadrant theta values are taken from 3 pi by 2 to 2 pi. Okay, 3 pi by 2 to 2 pi. That is 3 pi by 2 to 2 pi. So x belongs to 0 to 3 pi by 2 union 3 pi by 2 to 2 pi. Okay, cos x and cos x values are less than or is equal. This is we don't want because whenever positive the our required area got it. So now we take y is equal to cos x function. Table. X values, y values. X is taken 0 to 2 pi now. X is equal to 0 with the difference pi by 2 we can take it. X is equal to 0, then cos 0. Cos 0 value is equal to 1. X is equal to pi by 2, then cos pi by 2. Cos pi by 2 value is equal to 0. X is equal to pi, then cos pi is equal to minus 1. X is equal to 3 pi by 2, then cos 3 pi by 2 is equal to 0. X is equal to 2 pi, then cos 2 pi is equal, cos 2 pi value is equal, then y is equal, cos 2 pi now, cos 2 pi is equal positive 1. Okay, so that points are 0 comma 1, pi by 2 comma 0, pi comma minus 1. Next one 3 pi by 2 comma 0. This one is 2 pi comma 1. Fix these points. So this is O అంటే 0 comma 0 point. Next, taken as values 1, 2 on the y-axis. This is x-axis. Okay, now take the values on the x-axis. So with the difference pi by 2, 0 to pi by 2, pi by 2 to pi. This one is 1. Next pi 3 by pi 2. the points. 0, 1 in the first point. 0, 1. And the y-axis taken as 1. 0 to 1. The coincide point is this one. Okay? 0, 1. Next one, pi by 2, 0. Pi by 2, x base pi by 2, y base 0. So that is that. So next, pi, minus 1. Pi and the y-axis taken as minus 1. So minus 1 is downside now. So minus 1 here. So pi. Pi to minus 1. That's the pi. Next, 3 pi by 2, 0. 3 pi by 2, 0 point is this one. Next, 2 pi, 1. 2 pi, 1. Coincide point is that is. Okay. So now join all the points. This is x is equal to 2 pi line. X is equal to 0 line is this one. X is equal to 2 pi line is this one. So fixed points are taken as A, B, C, D, E. This is taken as F. So our required region, got it? Yes. Now we can find the area. Okay? We can find this area. The required area. A equal the area of the region OAB plus next the area of the region BCD, this one, BCD plus next one is DEF, the area of the region DEF. Okay, so now we take the formulas. Modulus A equal modulus integral first one area of the region OAB. Intervals are taken from 0 to pi by 2. 0 to pi by 2. Here the point is pi by 2, 0 now. So 0 to pi by 2 we can take it. 0 to pi by 2. So here function y is cos x dx plus next one the area of the region BCD. That means pi by 2 to 3 pi by 2. Pi by 2 to 3 pi by 2. We can take the intervals. X is equal pi by 2 to 3 pi by 2 cos x dx plus modulus integral x is equal 3 pi by 2 to 2 pi cos x dx. Okay, now we can find the values. A equal modulus integration of cos x. Formula is sin x. Taken intervals from 0 to pi by 2 plus this is also integration of cos x sin x. Intervals taken from pi by 2 to 3 pi by 2 modulus. So next sin x start region is 3 pi by 2 to 2 pi. A equal modulus apply the upper value minus lower value function. sin pi by 2 minus sin 0 plus sin 3 pi by 2 minus sin pi by 2 plus sin 2 pi minus sin 3 pi by 2. Take the values. Sin pi by 2 equal 1. Sin 0 is equal 0 plus modulus sin 3 pi by 2 is equal minus 1 minus sin pi by 2 value is equal 1 plus sin 2 pi is equal 0 minus sin 3 pi by 2 value is equal minus 1. 1 minus 0 taken 1 plus minus 1 minus 1 minus 2 plus 0 minus into minus plus 1 that equal 1 without modulus. Minus or plus, they take it the positive value now. So 1 plus 2 plus 1. 1 plus 2 plus 1, 4. So our required answer is 4. Therefore, A equal area of the region equal 4 square units.